And welcome back to another 3D Hangouts. Hello, everybody. I'm Noe Ruiz, designer here at Adafruit. Join me every week, Brother Pedro.
What's going on, everybody? Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printing projects featuring electronics from Adafruit.
I sound like a pastor, like Brother Pedro. No. He's my real. Anyway, welcome to the show. This is the show where we combine 3D printing DIY electronics to make inspirational projects. This week's coupon code is iTint. Welcome, everybody, in the chat room. We are live streaming here on YouTube. It is Wednesday, March 15th. I had to double check. It is 11 a.m. and episode 100 and something. I don't know. Over 100, you just stop caring. We've done this enough. Anyway, if you use the coupon code iTint, you get 10% off your order. We still got some cool things going on. There is a lot of snow happening in New York City, so if you don't get your package, don't hate us. We are working hard.
UPS is actually trying really hard to get all those packages out.
Yeah. But if you order something that's $200 or more, you get free shipping. That means if you buy a printer, free shipping. If you're in the US.
Yeah.
Yeah. We can do that here in the US. Same day delivery. I think that's maybe today, maybe not. There's a lot of snow, I don't know. A lot of uncertainties. Yeah. But I'll tell you what's not uncertain. You'll definitely get something in your inbox if you're subscribed to adafruitdaily.com.
Those actually just went out right now. We got really cool categories like MicroPython, electronics, biohacking, wearables, and of course 3D printing.
CircuitPython?
That's in the MicroPython newsletter.
Right.
So if you want to get your daily dose of news, tricks, and
tips and stuff you may have missed,
subscribe to that. It's at adafruitdaily.com.
Yeah. What do you do next?
Let's jump into this. Yeah.
All right.
Let's jump into this week's project video.
Did y'all get to see the video? I hope you saw the video. This one. Bip. Check it out. We got a guide. This was fun. This was fun to work on. Pedro, what is this thing?
So these are a pair of LCD controllable sunglasses.
Yeah, they come different names. Liquid crystal light valve is kind of what it's named, but it's also an LCD controllable blackout panel. Mm-hmm. So the idea is that this is sort of the stuff that's used in electric welding helmets for welders. Mm-hmm. So you apply some voltage to the electrodes on the glass, and it gets dark.
Those are really cool.
Yeah.
So this was actually inspired by one of the projects from Naomi Wu, aka Real Sexy Cyborg. She made like a whole suit out of these.
Yeah. Right here. Yeah. She made a whole suit? No, she made a top.
And
did she make a skirt too?
I think a skirt as well.
I think so. So if you haven't
seen that, should be playing the video
I hope
here.
You have.
Yeah, check that out.
She's got a great build video on it. Hers was way more advanced.
Oh yeah.
Because it's wired in series, or it kind of looks like it's wired in series, so that they kind of turn off intermittently. Like each one kind of turns on and off. Very, very cool. So the idea that Lamar and Phil had was to make them into sunglasses. So Pedro took it on himself to make that happen.
Yeah. So this is what they come in.
They come in a nice box. Let me flip the switch.
So this is product number 3330, and it's just a little LCD panel like this.
Yeah, it's glass. Be careful. It could break.
Yeah, so
you can't cut it.
You can't cut this. You can't bend it.
Unless you have a water jet.
Yeah.
Maybe you could cut it. That looks good.
It might break if you do that, if you cut it with a water jet.
Yeah.
But yeah, once you apply, it's about 3 to 4 volt.
Yeah, I think 5 is the max.
Yeah, it will darken and then lighten up. So the way that Naomi was doing it was with an Arduino to control the PWM on it, I believe.
Yeah.
And there is actually a way to do this with just a resistor to allow the light to leak out once you turn it on and off. Mm-hmm. So the way we did that was just with a simple little female JST extender, and then we just hooked up a little 10K ohm resistor on there.
Yeah.
Right across the side, so we can drain the tinted once you turn it off.
Do you want to see the circuit diagram?
Yeah, so it's a super simple circuit. There's no programming involved.
Yeah, it's just analog circuits.
Mm-hmm.
There's the resistor right there.
Yeah. So the reason we had to do that is because we have to have the resistor on the outside of the slide switch. So of course we had to build a slide switch adapter, which is one of those things we have to build for like every single project.
Yeah, a lot of projects use this.
Yeah, we don't want to cut into a LiPo battery, and this is like the easiest way to turn to cut power from the circuit.
Yeah. Yep.
So it's pretty simple. It's just a slide switch, a male JST on one side, and then the female on the other side.
Yeah.
We just connect the battery onto this side, and just that allows it to turn on and off.
One thing I want to note is that the JST extension cable has the male and the female, but we don't like the female connector because it's a little bit flimsy. We sell these extra ones that are a little bit more beefy and they won't melt as easy.
Yeah.
So that's why you can tell it's different. It's black. You can pick these. I think they're like $1 or something.
Like 95 cents, I want to say.
Yeah, a couple
or
cents to
$1.
pick this thing up.
Oh.
Yeah, so I recommend using these ones along with the extension cable.
So we took a look at the 3D printed enclosure. So we have a frame that houses the LCD panel. It just snaps right in. And then we have the hinges and the arms on the side here. So in the video I show how to do it with a paper clip, but a much better approach is just using 1.75 millimeter filament.
I'm going to focus there.
It's really because of the color. It totally blows out anytime we try to record stuff with it.
Yeah, the color's very bright.
Yeah.
There you go. How's that?
There you go. Yeah, so it's just a piece of 1.75 millimeter filament pushed through there, and then the ends are heated up and then pushed up against it to create a rivet. That works very well. So I showed the paper clip method just in case you have you're using 3 millimeter filament and don't have any of that lying around. So if you go back to the focusing,
Sure.
the two pins that we're using for positive and negative are the two top ones here, and then we just have a little channel groove that you can hide the wire to the leftmost.
Yeah.
It's running into the arm that is housing all the electronics.
Yeah. So those electrodes are they're not really polarized. They you can kind of use. It doesn't matter which one's negative or positive.
Yeah.
So they have two sets of these electrodes. So you can see that there's one here and one here. But the way it is, like, both of these would be ground or positive, and then this one would be ground and negative. Is that correct?
Yeah.
So
if we take a look on the bottom here, where the side switch is protruding, it's pretty easy to enable.
Please.
Not really much to see, just a slide switch.
Okay.
So just put it up near the front here to make turning it on and off super simple. And then the lid on top here is just a snap-in.
We didn't really cover this in the video, but it does have a lid. You do have to snap it on.
Yeah. Get that off.
So
you can take a look at the circuitry inside here. So super crammed in here, but still enough space to slide things around and enough room for coiling all of your wires, so you don't have to actually cut any of the wires for the battery off. They can just coil up. And you can see the two female JST connectors inside there, and the slide switch all fit nice and snug in there. And now to make sure that we have a super strong wall, because it is pretty thin, I didn't want to make it so thick that it's going to look funny on or mess with your ears when you put them on. We do have to do some little trickery inside of the slice settings. So if we jump over to Simplify 3D,
yeah, sure. Let's take a look at this.
and take a look at how we set the file up for slicing.
Let's get the right file in there. So what I'm using is the FlashForge Create Pro. Is that okay?
Oh, that's fine. This should be with any printer, actually. So most printers have a 0.5 or 0.4 millimeter nozzle on there. And when you're printing, sometimes you're constrained to sizes.
Wrong one.
And you want to make sure that your walls are thick enough. And when you have a bigger nozzle size, there can be some gap in between the walls, which will make it squishy. Sometimes you want those properties, and other times you just want to make sure that it's solid, it doesn't have any give to it when you bend the walls. And the way to get around that when setting up this file is dropping the default nozzle size down to 0.3 millimeters,
Okay, 0.3.
as well as the extrusion width
Extrusion width,
down to 0.3.
0.3. Gotcha.
So now if we go ahead and slice that, you can see that there are actually two perimeters right on the inside between the walls. So if you go through the slicing, you can see that it is nice and strong. There's two additional parameters on the inside.
Oh, is that two?
Yeah, to give it strength. that's how we were able to do that. And if we, probably actually should have showed it at 0.4 millimeters to show that there's a nice noticeable gap between those.
So if I were to use the default 0.4 with an auto, you might get some undesired results. Yeah.
Yeah, if you take a look at the inside
very
there.
Thin.
So when I tried printing it like that, it was noticeably squishy, I want to say. And the layers did
flexible,
separate.
It wasn't as sturdy, it wasn't as
yeah.
rigid, it's got a lot of play with it. Yeah.
So when attaching the lid on top, it would separate the two layers because of the friction.
So 0.3, 0.3.
So for those of you using Cura, there is a way to do this that you discovered. I think it was the...
I'm not sure. If you guys know how in Cura, let me know. I know there's a bunch of settings in Cura. This is the new version 2.4. There might be a newer version, but in this version it seems to handle these gaps a little bit better. What did I just do? I don't even know. I moved something.
Every time you move it, slices it.
Yeah.
I wish there was a way to disable that.
Okay. So back to Simplify 3D. That's the magic number, right? So 0.3, 0.4.
Now this actually came up earlier when you were doing your for the Featherbox design. Bill Binka was actually having problems with it being not as sturdy because another setting that we'll talk about again, but we might as well run through it right here as well.
Okay.
If you go over to your Advanced tab, you can take a look at the thin wall behavior, and if you have used thin parameters for thin walls, you actually have to bump this up to 50%.
Yeah, by default it's probably like 20 or something.
Yeah. So if we slice it at 20%, you can see that it's not going to fill it up all the way.
Yeah, that's still hollow. Yeah. Even with the 0.3 update to the nozzle and the extrusion width. Yeah, 0.3, 0.3. So you do have to crank this up. I thought this was independent. Like I thought only this would apply to that, but it's not the case. So always have it at 50%. You can't go any higher than that. That's as high as it goes. But that's the magic setting you need to get these 3 perimeters. There you go.
And that's just a trick that I find myself using a bunch of the times when you are constrained to a certain wall thickness or a size of a geometry. Make sure you don't have to increase the size of that just to have your nozzle fill in the wall gap. Another thing that we had to do for this, we do need support materials for the hinge part and the arm or curvature, and then the inside of the wall. So to set this up, to make it very easy, we just increased our pillar resolution up to 8. And then if we click on Add New, we can go right over the hinge part, click once instead of having to like click, add like 4 different pillars on there. We can just have one by increasing the pillar size of that.
Should probably move it in a bit more. Like right there.
That's pretty good, yeah.
All right.
And then we used a 4mm pillar size for the little curvature of the arm end.
So 4. Let's see if we can get this right.
Yeah, so usually this would be fine. I did print it without supports, but you do get a bit of warping for the outer curve on that.
What do you think, 5 is enough? Maybe 6?
Right there should be fine. If you turn around,
that should be
perfect.
At that point, the printer will catch it.
Yeah.
Here. So we're not done yet, though. We still need some more supports.
Yep. So underneath, we have the walls that are holding the slide switch in place.
Yeah.
So to fill those in, we can drop the support resolution even smaller. In this case, we dropped it down to 2 millimeters.
Where's the wireframe mode? Is it? Yeah. So this button here lets you kind of see the facets a little bit better. Is it facets? I don't know. Subdivisions, whatever.
The faces.
2, right?
2. And then we just add them to the corners.
1, 2, 3, and 4. And then I think 3.
About 3 for the middle part there.
3.
And then when we preview this, we can take a look at how all of these combine together.
3.
So another setting that you want to enable, if you go into your support tab for the process, we want to make sure that we have extra inflation distance enabled. 1 millimeter should be fine. So what this is doing is connecting all of the pillars together so that you're not overworking your extruder by
Having to stop,
retracting,
start and stop, yeah.
retracting, and for each individual pillar, it'll just do one entire sweep for that entire section of the support material.
I believe 30% infill support is default, which is fine. The dense infill is 70, which is fine, right?
I sometimes drop down to 30%,
What
and
is
for the
one?
dense infill percentage.
Right.
But the 70% should be fine.
Yeah. What about the
Horizontal offset for the FlashForge 0.3 should be fine. On the Sigma BCN 3D, I set it to 0.7 millimeters, and that works
And
pretty well.
what this setting does is it just makes it so you have a little bit of air gap in between your support and your part, so it doesn't fuse together. So the more you increase it, the more air gap you have, and the less sort of scarring you'll get.
Yeah.
And it'll be easier to remove these supports. So let's check it out now, see what it looks like.
And there we go. We have one continuous.
Yeah, you can see how the support material over here starts. It just kind of zigzags over here. I think that pillar or that thing is kind of intersecting with it.
It will,
I
yeah,
can
but it
turn
should
that
be
off.
fine.
Okay, I can turn that off. If we look here, looks like I need to have them a little bit closer together,
Yeah.
right? So they're not fully touching, they're not connected. These are connected though. If I just get rid of that that brim, I guess it is, right?
Yeah.
Leave that brim for now. There you go, no intersection there. And then I just would have to just kind of bring in these a little bit better. Do I have to
And
delete them
closer.
or can you move them?
You can just add to it.
You can just add to it. That's probably the better
Yeah.
thing to do.
And the reason we don't
Down
want to add any in the, right in the center of it is because you won't be able to. Simplify only allows you to add pillars underneath a geometry. You can't just place one floating in the air, which is why we're using the inflation distance setting for that.
may have overdone it, but I think it's okay for this test here. There you go. Now they're touching a bit better.
Yep, so that'll be all one continuous sort of loop.
Yeah, one continuous path. That
Path.
the tool path that the printer takes. So you can see how it starts it off. Then that just gives you a better success rate of printing the supports. It's so tiny.
So those are the tips for printing out the geometries for that. Make sure you have all the wall gaps are filled in by decreasing your diameter size and your extrusion width.
And if you're wondering about the top has a lot of bridging. It just connects itself beautifully,
Yeah,
which is nice.
it's not so
There's enough
such a
top
big
layers.
bridge, so it
Yeah.
fills in very nice.
Yeah. There you go. That's how you can create these kind of complex shapes that really aren't optimized. I mean, it's optimized for 3D printing in the sense that you're using support material to achieve this.
Yeah.
This very specific shape.
So you're doing
Geometries.
this exact setup for the glasses or the arm that doesn't have the enclosure for the circuitry inside there.
Anything for the frame?
For
Any
the
supports?
frame, I didn't use any supports on that actually.
Cool. Just print it flat.
Yep. And for the rest of the geometry, you could have the default nozzle width and extrusion width for that, just at 0.4 millimeters, and it should work out pretty
Excellent. I hope you all enjoyed that. If you have any questions about it, let us know.
good.
Or have any other solutions or ideas and stuff, let me know too.
Yeah, so one of the other projects that you could add these blackout panels to are any sort of cosplay, or John Park actually had a really good idea for doing an escape room where the refresh rate on a TV
That'd be cool.
would be like a secret hidden message or whatever.
So you can get out the room.
Yeah. So the refresh rate would equal to whatever you set the monitor at. So it's constantly blinking like that, and it's blacking out whatever message that you want to hide into a display. So it's a really good way to control the shutter for that.
Oh.
So that's really cool. And the Fusion 360 files are available, so you can customize these to adjust the hinge angle of these. So if you have like a bigger head, you should be able to update all of the sketch dimensions, so you can adjust the curvature of that.
Yeah.
I did attempt to make one that had two of these, so you can have one on each eye, but it just looks
comical.
It looks comical having such a big size on each eye.
Yeah. I remember when you showed me, I was like,
But yeah,
Maybe
super simple, cool
Cyclops.
project. You can build, mostly we're using these when we're testing out NeoPixels because they're so bright, and it's a little bit of a hassle to go into the code to change just the brightness of it. So you can see that it makes a huge difference when you have it on, especially when you're looking right at the NeoPixels like that.
Yeah, some folks are saying that there's no UV protection from these things. Is that true?
You know what? I don't know. I didn't look at the data sheet for any UV protection.
Yeah, we'll look at the data sheet, but...
Again, these are used for welding helmets, so I don't know if there's any UV, like when you're melting metal together, but there you go. It's a good little use of it that we'll be using it for testing out our NeoPixels.
Okay.
Check it out.
Or just to look cool outside. All right. Hey, Angus from Maker Muse is in the house. Hello, Angus. How you doing? Thank you for joining us. I wonder what time it is over there. It must be kind of late. Anyway, give everybody a shout out to Angus of Maker's Muse. All right, what's the next topic?
All right. We can switch over to this week's layer by layer.
Can I show my featherboards?
Yeah.
Okay. So I did a live stream yesterday where I kind of showed you guys the progress update on these. And I just want to show how nice it is. This is such a nice opportunity to have all the glowy wet feather wings all in one place and all turned on, looking nice. So this is cool. So this project, of course, is a sort of multi-purpose enclosure for the feather line of Adafruit boards. And the goal of this project is to have a kind of easy way to make modifications using parameters. So it's parametrically driven. So folks can go into the CAD file and update them. But we plan to have a bunch of kind of preset made ones. So ones that have battery compartments, ones that have mounting tabs, different toppers for different applications, lots of different things. And if you want to know more about it, you can check out my 3 past streams on coming up with the Featherbox. What I did since yesterday was just did a little bit of CAD cleanup. So I'll show you guys real quick. I think I have it. Yeah, so I kind of reworked it. So before I had all the components kind of out there, and now I have sort of this master assembly for the components. So you can see the slide switch and the feather wing OLED is there. The main feather board is there, and a couple other components and things. So they're all now nicely grouped inside one components object, so you can kind of hide them and show them. The other thing that I really wanted to do was, what is up with that filament spool?
It's just wound too tight.
Okay, I'm gonna unwind it because I don't want this to fail. Sorry, live show. Oh wow. Oh no, it's, okay. Just give it some, you know when it gets too tight and it's like binded? Mm-hmm. Oh man. Oh, it saved the day. So what I really like about remaking this is that my timeline is kind of massive, right? It's kind of hard to go in there and find things. So by separating everything and breaking it out into its own component, I can clearly get a better look at all the stuff. So if I activate this case component, you can see that the timeline is now just all of the stuff that pertain to the case. That's a setting that you can change or turn off. See where it says this little cogwheel at the bottom, hide all inactive features is turned on. If you turn that off, you'll see all of the components. It's just a nice way to kind of have everything. So each component has its own set of sketches, which is nice. They all have their own set of construction planes as well. So that just kind of makes digesting all of the components easier. So you can see all the sketches that are pertaining to the battery holder are in the battery holder. And this one's a little bit lighter. There's a lot of features and stuff made for the case, which I think is the most beefiest one. The topper one, probably even less than that, yeah. But I'm printing out, obviously, something right now in the background of this to make sure all the tolerances match out. I did run into a little bit of a problem with these little connectors right here that connect the battery holder to the case. So hopefully that works out well. There is a little bit of clearance for tolerances. It's about 0.4 millimeters, which is a little bit more than I usually do, but I I think for this size enclosure, it makes sense and it works out pretty well. Another thing I did was I wanted to shift over the board itself because it was like on the edge here. So I moved it over a little bit, and by doing that, I had to kind of bring in this indentation for exposing the USB port in more. And when you do that, you kind of have to add a little bit of material inward inside of the enclosure. So this kind of chunky mess here is so that the printer has enough material to work with, so it's kind of inset. So I think that works okay. I did a quick test, and that seems to work. But that's basically it. There's still opportunities to do some versioning and some branching so that there's just not copies of the same thing here, like the battery holder. There's one with the tabs, and there's one with no switch or no tabs. It's kind of like the basic one. And also what I did was I made these tabs parametric. So they weren't parametric before, now they are. So if somebody wants to make a really big hole, so right now it's at the 4. Let me change this to 8. Everything grows with it, like that. You saw that?
Very cool.
Magic. That's cool. So the kind of material around the hole is it grows with it. So it's all parametrically driven. I'll set it back to 4. There you go. So if you want bigger wings for your tabs, you can do that. So again, I'll share this file once I validate that it works. And I also have a couple folks that are printing them out in different materials like ABS and PETG. So hopefully that works out good.
So to reiterate the problem that we were having, or that Bill Binka was having about the wall gap.
Yeah, we can do that. Want to take a look at that? So let's take a look.
It seems it's a problem that always comes up when trying to print.
I kind of forgot it too. So I'm going to bring in the enclosure and show you guys what's the expected tool paths. So for example, I got this battery holder here. If I were to go over here and let me change this back to 0.4 and auto, that's kind of what you're going to end up with. 100% for the multiplier or 1.0. And so right now it's set to 50, right? But this was set to 20 on Bill's profile. So if you check a look at that, you'll see that all of this, and there's support material. I don't need support material, but don't worry about that. You'll see there's a big gap in between the outer and the inner wall perimeters. So there's a lot of this kind of gap in there. And the ideal thing to do is to have that filled in with a single perimeter, right? So it would be a total of 3 shells.
So there are instances actually when you would want something like this, like if you want something to fit in very well, to be able to have a little bit of give to sort of tighten up around something. But in this case, we want the edges to be nice, sturdy, and rigid.
Yeah. So all you got to do is just change under Advanced tab, Thin Wall Behavior, just crank that up to 50. Again, it doesn't go any higher than that, so crank it at 50. Take a preview of it, and now it has 3 perimeters. Yay! Look at that, all nice and
optimized because you do not want that zigzag behavior.
Yeah, you notice this stuff here too. These little walls that hold the slide switch in place. Yeah, that has it as well. And so do these little protruding nubs that connect to the battery. They're right there. And the blue color is just indicating what speed. Yeah, speed. So there you go. Quick tip on that one. Box, feather box.
So yes, you are working on the TFT feather wing for this.
Yeah, I had forgotten that I kind of made an enclosure for the TFT feather wing. It's called the Feather Weather Box.
Yeah.
So it uses an ESP8266 to pull weather from underground weather API. You could check that out. I will work that into this design so that it's kind of parametric, because the other one is but isn't really.
Yeah, it's like in the shape of a nice little cute computer.
Yeah, it's in a specific shape too.
Yeah. So if you guys want to pick up any of the filaments, of course all of the feather wings and feather boards.
They glow.
We got so many. These aren't even all of the different
there's
ones.
a lot.
There's so
you
many.
Can see if you want to pick up any of the boards, adafruit.com/feather.
I have a nice little landing page to go over every single one of them.
So
Someone's
many
actually
glows.
making, she's actually working a bunch more too.
Yeah.
A little MP3 feather wing. We have doublers, triplers, LoRa radios,
Yep.
RTCs, blinky servos.
Motors, relays.
Fastest way to get a Arduino project, and
a nice compact version. It has all the circuitry you need to do charging as well, to charge your battery if you want to make it portable.
Yeah. And of course,
Like
we
we
will
have
be
here.
moving over to MicroPython as well, so be on the lookout for
all
those.
the SAMD chipsets.
SAMD 21s coming out. Oh man, so excited for that.
Yeah.
If you guys have
Especially
ever
for Bill and the AT folks, they could really use a better way to get their software onto their board.
I think I say this
installing.
every time we talk about the SAMD 21 and MicroPython. It's like, oh my God, I wish that when we started,
It was like that.
it was like that, because it's literally
the learning
just,
curve is like, okay, download some software, learn how to install libraries, and learn how to configure your board.
this is literally
Which is
plug
easy
it
to
in.
us now, but when you first do it, you're just like, what am I doing?
I know.
But
So
we
it's
do have
confusing.
guides and things that walk everybody through it, so at least there's that. Okay, so if you do want to check out this week's project, again, you can use this coupon code, get some monies off your order, and be sure to check out Pedro's guide if you want to take a look at how he built it, and if you want to build your own.
All right, let's jump into this week's shop talk.
Okay, let me switch things. Shop talk.
So I was a little bit in a
There we
rush to do this week's Time-Lapse Tuesday, and Noah, you actually found this super cool little lighthouse.
Yes, I did. This is thing number 204347-2. You can find it. It's I don't know how to say it properly, but I'm going to say like Kilauea Lighthouse. It's a lighthouse in Hawaii. So you can check that out. Here is it in the flesh.
So you might have seen Time-Lapse Tuesday for this. It came out very nice. Very surprised on this. It's all completely hollow, so it prints pretty fast. And the thing I really like about this is you can definitely use this like as outdoor
Outdoor decor or something?
decor. Yeah, if you have like a beach theme outside or something like that.
Sure.
And the other cool thing is with like a photo cell, you can have, you know, an LED automatically turn on when the when it gets
When the
to
sun
dusk
sets.
or something. Yeah, it looks really nice with the LED inside. They were just using a little gemma with a jewel inside there to make it nice and glowy.
Yeah.
You could of course go over the top and add like a little motor to sort
make
of
it
rotate
spin.
the light around, but
Like a real
as a
lighthouse.
nice simple little print, came out really nice. Big shout outs to
The
designer
designer,
on
yeah.
this. Modeled all in Fusion 360, and everything prints in, there's it 5 different parts.
John Garham designed this. It says a little story. His friend wanted him to build one, so he sketched it and then he 3D printed it. His friend did, so that's a good little collaborative effort there. As far as optimized for 3D printing, it's pretty good. It's hollow, so we can show folks.
The one thing we wish that he would have shared the Fusion 360 files to add like coils in there, because right now it's just a press fit for all the parts.
Yeah, it's relatively easy to add coils. I have a tutorial if folks want to know how to do that, and I'm a big fan of coils.
Yeah. Like we all
Or
are.
threads too. Threads are nice. But coil lets you make your own custom thread, right?
Yeah.
Cool.
Best way to make
Any,
an enclosure, I think.
I had one thing I wanted to say to better optimize this even more, is that if you look at inside, it's pretty
It's pretty thick.
it's kind of thick. To make it thinner, what you could do is instead of punching out a cutout, you could shell this out. That way, the shell kind of adapts around these insetted windows, so that you don't have to kind of make it thicker, because obviously you make it thicker so that you have enough material to actually print these insets, windows. So if you do a shell, the shell's smart enough to kind of adapt around
it,
those,
yeah.
and you'll end up seeing this kind of insetted inward, but you won't have to worry about any overhang, because they're already chamfered out here, and they would be chamfered as well, because the shell's smart enough to do that. So I think that's the only thing, though. Everything else is pretty nice.
Adding that, adding the coil, maybe have the doorway open so you can like stick stuff
Yeah,
inside.
it looks like there's a little draft. It's an angled surface, so that there's a little bit of overhang, but not that much. Your printer can handle it.
Yeah, I did print this at 0.3 millimeter layer height, so,
Right. So there is a little
the
bit
overhang
of,
is noticeable
I
on
don't know if you
that.
can see that. Probably can't, but
Alpha
There you go.
SX Signal is saying that you could stick a security camera inside there. It's a good idea.
hide your
Point
second
it out,
camera.
yeah.
That's a good idea.
Put the little the server on there so it'll rotate.
I think I would print it
Or
bigger.
360.
Yeah, so it's not like just angled down.
Mm-hmm.
Prints it a
Hang it
little
up
bit
or
bigger.
whatever. Yeah, very nice print. You want to have some blinky in your yard.
Brinky Lighthouse.
Very cool.
Awesome.
And moving on to this week's community makes.
Yeah, I didn't have them this week, but thankfully Kirby came to the rescue and shared this with me. I also saw this last week on Maker Update from Donald. Yeah, Maker Update. So this is from Circuits.io, shared on Hackster.io. And it's just a bunch of like 3D printed little enclosure and holders for various components. So battery holders, LCD, 7-segment displays, looks like a nunchuck, for a Wii nunchuck type thing, battery holders, motor holders, a bunch of different things. So check them out. It's just a nice assortment of different 3D printed holders. The potentiometer holder looks really cool. Battery holder. I kind of did the same type of design for holding buttons, which is
Mhm.
good. It's a good way to do it. Good stuff. So check those out. And check out the Circuit.io team in general. They do a lot of cool other projects, a lot of nice GIFs. This one was really cool. This 3D printed air gate for drones. So it kind of
That's
turns
actually really
green. I think it has a proximity sensor or an IR sensor something,
Mhm.
so that when the drone comes by it, the LED will change, so you know if you
Went past it or not.
So that's cool.
Super cool.
All right, lots of other cool stuff too. So check them out. That's Circuit.io on Hackster.io. I'll have the link after the show
Mm-hmm.
in the description.
Sort of looks like a Wii controller for the joystick, huh?
Yeah.
Really cool.
iTint.
If you want to pick up printers, filament, all of the electronics that bring your projects to life,
Yeah.
don't pay full price.
Tomorrow we'll have a lot more projects that will be shared on the blog, including Angus's project, which is pretty awesome.
Oh yeah. Really cool.
So we'll check that out tomorrow on the blog. I think is that it for that?
I
that
believe
one?
that's it.
Okay, cool.
We can jump
Q&A.
into this week's Q&A.
Yay, Q&A.
So Scott Watson is asking about the Magpie that featured the Pi Girl.
Sure, what about it?
We mentioned about the Pi Girl 3. It's happening soon. Wanted to know if we were going to combine a Super Pi with a 5-inch screen.
That would be really nice. What I want to get away is from using frame buffer tools. So like all the
Yeah.
Pi TFTs, they kind of have to do kind of a hacky way to do it. It's not HDMI.
It's not optimized, so you
Yeah.
are going to get slower frame
You
rate.
get slow frame rate even with an overclocked
Mhm.
CPU. So yeah, that is in the pipeline. It's a little bit of a project, so
Yeah, all the Pi projects will be updated this
yeah.
year.
I mean, I'll share. I'll do live streams when I get started on it and ideate with it, so folks can kind of collaborate with me on it. I
Mhm.
think that's a cool approach.
Yeah. Thomas is asking, is the new version of Cura compatible with a MakerBot Replicator 2?
I'm not sure. The Rep 2 has an X3G wrapper thing that's kind of weird. Simplified 3D can do it fairly well. They have it kind of integrated. I'm not sure if Cura can. Yeah.
Jim is asking that we're changing the nozzle setting without physically changing the nozzle. That
Yeah.
sounds wrong.
That sounds wrong. It feels dirty too, but hey, it works.
Yeah.
Yeah, it's really about getting the toolpath the way you want it.
The extrusion. Yeah,
You
there was a
could-
nice little graphic, I forgot where it was posted, that showed all the different nozzle sizes and the minimum and maximum extrusion width and the layer.
Wow.
The minimum and maximum layer height
Where'd
that
you
you're
see
able to
that?
print. I don't remember.
Oh,
It's on Twitter, I think.
okay.
But it had a nice little breakdown of what the minimum and maximum extrusion width and the minimum maximum layer height that each nozzle size can do. Can we make a printed project can we make a 3D print project for every AdaBox? So far it's been the robot chassis, and then before that it was just like a kit to sort of build a number of projects. The next one You can kind of tell by all the cloud pictures, teasers that we've been showing
IoT?
off. Yeah. So there are already a bunch of projects that we've made that will utilize any of those constraint sizes for the boards. So let us know what project you'd want with the Ada box, and we can point you into a direction or update any of the project files to fit any of the components inside there.
Cool.
Let's see.
Kirby has the thought of using HDMI connectors and soldering thin wires to make a compact connector to use with the HDMI display from the digital camera monitor project we did. Yes, that is...
I do have the enclosure for that.
What do you mean the enclosure?
The little breakout that we have for the HDMI.
Okay, so we have they come in separate little breakouts, so you can solder directly to these little pins. I think that's a good idea.
Mm-hmm.
I think I might want to do that for the Pi Girl project as well, kind of make my own HDMI cable, because there's the bit where the metal is
So
to
big.
the actual wire is such a long thing that it really takes up a lot of real estate in your enclosure and ends up taking a lot of space.
Yeah. Oh, hey, shout out to Bill Binko.
Oh, hey, Bill.
Just joined us.
Yes. Earlier in the show, we talked a little bit about the Feather box update. So I have updated those little nubs so that there's a tighter tolerance on them. So I'm printing them out right now in the FlashForge, and I'll let you know if it comes out good or not.
Yep.
Hopefully it does.
Thomas is asking, do we have shop tours or visitors at the factory?
No, unfortunately, we do not.
we
We're
do
not allowed
not.
to do that.
No. It's an actual factory.
Yeah.
We
There's
can't
too much
just
reliability.
Yeah.
We don't want people to fall into the river of chocolate and get sucked up. But it's a good lesson to learn how a gun works, right? Pressure.
Yeah.
Ooh.
Yeah, we don't have a storefront. Until they all close out, you can check out some of the products over at Radio
Until they
Shack.
all close out.
At Radio Shack, you can pick those up. Yeah.
What are your recommended 3D printer software? For slicing or for modeling? For slicing, Simplify 3D, hands down, best slicer we like. Second runner-up is Cura 2.4 or higher. Cura, however you want to say it.
Kirby, it's a river of solder. Yeah, we can't.
Yeah, there is
Yeah.
a river of solder.
Although I did take Gavin there when he was, I think, 1
Don't
year
tell
old,
them that.
2 years old.
Don't tell them that.
But I held him. He was a little baby. He couldn't run anywhere.
Yeah, now he would not be allowed. Sorry.
No, employees, kids are allowed to go, but no, not anybody else.
Fusion 360 for the modeling. That Onshape is also a good choice as well. Blender, open source, if you want to learn the UI. My parts are done. You want to take some more questions? Let's see. I'm such a huge fan of the print and Z plates. They just work. Like, I love it. It really beats tape because you get this really nice flat finish.
Maker's Muse, Angus is saying that you can push 1.5 millimeter extrusion width through a 0.5 millimeter nozzle.
Wow.
If you're brave enough.
If you're brave enough. Well, does it reduce the quality of it, or is it like kind of?
I don't know, I haven't tried.
Huh. All right, so these are the two new parts that I just printed. All I kind of did was I made these a little bit tighter so that there's more grip on them. Hopefully, feel that nice clip there, nice clip there, and there's no
nice.
give here. Oh man, that's nice. Taking them out is a little bit of a challenge. You do have to kind of fit your fingernail in there, or better yet, a piece of a spatula or something thin enough to get in there to break these two. You could even try pushing these tabs in because they are kind of locked in place, but the idea is to kind of keep it locked in place without having to use screws or any glue, so I think that'll work out. Bill, I will send you the STLs, or you can jump in the project. It's called Featherbox version 2. I reworked it so that everything is a little bit more digestible. Oh wow, there's a big problem there, look.
Oh, your
Never
wall
mind,
thickness.
don't print that yet. Look at that. This is live. I'm surprised that printed. Yeah, the wall
So
thickness
thin.
was kind of wrong there. Whoops. That's what happens when you rush things before a live show. You get these very funny problems. The real thing was to kind of test this out, which works, so I don't have to worry about that. On to the next thing. That is ridiculous. Nothing like showing your mistakes live.
It's good. Stan is saying, do we have any practical printing model? Something useful, for example. So I don't know if you missed what these boxes are for. These
Yeah,
are
they're for
helping
assistive tech. A lot of folks that.
So what is assistive tech?
Assistive tech is
people with
helping
disabilities.
folks with disabilities. Yeah.
So I don't know how you get
the
more
majority,
practical use.
Yeah,
than
the
that.
majority of people that get a feather box and they want to hook up a sensor to it to kind of monitor things, it's just hanging out. Wires are hanging out. They need to enclose it some way. So this generic multi-purpose box is one solution to hopefully many other problems.
So why would we 3D print them instead of actually going through them? Have you seen
3D print
what the prices of actual assistive tech buttons cost?
Yeah, there's a really huge disconnect. You should check out atmakers.org. I would go there first for a nice.
I'll mention this. A button that is certified assistive tech costs $60. That would $85. That's
if you buy it personally.
Rip-off. Yeah.
If you buy it through the proper channels, it's double, maybe even triple the price.
Oh my God, yeah.
Because there's lots of layers of bureaucracy and things.
Now you could also search YouTube channel. We've done over 300 projects.
Practical projects are fun to do.
Projects, yeah.
They're not all just cool shades that you can turn on and off.
Yeah, even though.
Although that might help a blind person that needs shades in the sun.
Yeah, I forgot we saw a video on.
Yeah, it was like a little mini documentary about a guy who's a passionate sort of astronomer. He kind of owns his own observatory. Him and his wife are blind, and he kind of needs special sunglasses to see out in the daytime. He's legally blind at night in daytime. But at night, he can actually see stars and stuff without. He's got like supervision at night.
Yep. So the practical 3D printing is pretty much what we focus on here. On all the electronic projects as you see, there's always a use case for them.
Yeah.
So
good stuff.
You can go through the 300 odd projects. If
you have those, it's a long story. It is.
It's a pretty long story, but so super useful.
Yeah.
Especially since a lot of people with 3D printers get them without any CAD knowledge, and they just sit there. They don't know what to print
that's
next.
sort of the goal for AT Makers, is to kind of connect makers and classes, education institutes, to kind of get kids to work on these projects and use their printers and learn some CAD skill and things like that. So it's good for STEM stuff.
So if you ever have the itch to make a difference in the world or actually help someone out,
yeah, it's a great way to do it, because you get to combine your passion of making and designing with helping people out. Which I think it's great. Cool. Well, that's going to be it for the show. Thank you guys so much for joining us. If you did want to pick up anything in the Adafruit shop, it really helps us. You support a company that is not funded by venture capital. It's all self-funded. We do these live shows and share as much information as we can, because we love to do it. And it's information is the best form of advertising. So
that's right.
Check it out. You can get some monies off. We have some great deals going on. So check out the Adafruit store.
Yep, that's the best way to support us. It's how we all pay for our 401ks here.
Yeah, there's a lot of folks in the
check it out
that have rent and things.
Yep. Yeah, rent is
in New York. It's kind of costly. Ooh. All right, so thank you guys again. Good luck, everybody, on your projects. We will see you later tonight. There is a show and tell at 7:30 p.m. Eastern Time, and there's a special edition of Ask an Engineer. It's Ask a Lawyer. We have some lawyers that Lamar and Phil are going to talk to. I'm not sure what it's about, but surprise.
IP.
IP stuff?
So intellectual property. It's actually, I think it's the Adafruit lawyers, actually, who's going to be on.
Our lawyers?
So, yes.
Awesome.
Tune in. There was some stuff that has happened at Adafruit that they came with their capes on to the rescue, saved us. So you definitely don't want to miss a story on that.
Somebody tried to sue us, huh?
Yeah.
Okay. Lamar and Phil are doing awesome live streams from the desk of Lady Ada. A lot of payphone hacking and giving stuff away. They broke the VoIP service.
You could call in now.
You can call in now. Maybe we'll do that too. You can call in the show and we'll do some live giveaways. As
soon as all the
if you want to win something, you have to call them on the payphone, hacked payphone.
So Desk of Lady is randomly. It's usually like around 10 or even
just subscribe
12.
to all the things to
hit the little bell icon to
for YouTube.
Get notified.
Yeah. I end up getting Periscope first, then YouTube. It's weird.
Yeah. So subscribe on all the channels, because you get like different angles of
things.
things.
All right. Well, that was a good closer. It's like the nice closer. Thank you guys. We'll see you later tonight. And if you want to join the show and tell, you can check out Google Plus thing.
Yep, we're always there. If you want to show off any of your 3D print projects, we'll be there.
All right. That's it. Bye, guys.
Have a great one.